In Chapter 3, we're going to start functions. So what are they? Well, first, we're going to determine what they are, whether relations are functions, and then we're going to do something that actually a lot of students have trouble with, and that's this. Find the domain and range of a function. And then we're going to identify the independent and dependent variables of functions. All right, so the first thing we're going to do is determine whether a relation is a function. Well, let's first go over our vocab words because you need to know what a function and a relation are. Now, a relation pairs inputs with outputs. So let's just go over the very basics. A relation is like this. The 0.54. That's it. That's all a relation is. When a relation is given as ordered pairs, now notice here, it's a relation. It's like a relationship between x and y. The x coordinates are the inputs. So the x coordinates are the inputs. The outputs are the y coordinates. And let me erase that there. So the outputs are your y coordinates. Now a relation that pairs each input with only one output. This is really important. Huge concept right here. A relation that pairs each input with exactly one output is called a function. What that means is this. 5's my input, 4 is my output. This input goes to one output. So if I had two ordered pairs, 5, 4 and 5, 5. This 5 would go to 4. This 5 would go to 5. So 5 has how many outputs? How many outputs does 5 have? It has 2. If I plug in 5, it tells me I'm getting 4 and 5. Therefore, this relation, each of these relations, this would not be a function. All right, so let's go over example 1. We want to determine if each of these relations, now remember again, a relation is a relationship between x and y. Now, I can give those in ordered pairs. I could give those in like a t-table. I can also give them as a mapping. So this is a mapping tool or a mapping diagram. Now, what we want to do is make sure that every input has only one output. So let's look here. -2 goes to 2. -1 goes to 2. 0 goes to 2. 1 goes to 0 and 2 goes to 0. What we want to look for is if the x values repeat themselves. So if we look at the x values, no x value repeats itself, which means no x value goes to more than one output. So, reasoning, make sure when you do your work, you have to explain. So in A, is it a function? Yes. Now, what's your reasoning? Your reasoning is that each input has one output. And I apologize, my stylus is breaking here, so I have horrible handwriting. But each input has one output, so A is a function. Now B, look at B. We instantly see that two ordered pairs have 4. Now some people think, well, wait a minute, I thought I'm looking for output, not input. Right here, we have one value. I know it's doubled, but you'll look at the x value as just 4. How many numbers does 4 go to? It goes to a 0 and it goes to a 3. So that means the number 4 has 2 outputs. Because 4 has 2 outputs, it's not a function. Not a function. And the reason would be, you would have to write this out. 4 has 2 outputs. So write that down in your notes. 4 has 2 outputs. Now look at the next one. Right off the bat, we see that 0 repeats itself. So 0 has 2 outputs. C is not a function. Now the last one, x does not repeat itself. X goes here, X goes here, X goes here. Each input only has one output. Now you'll notice that 15, two numbers have 15. But negative 1 only has one output. 3 only has one output. 11 only has one output. Now they're the same output, but that's okay. So D is a function. Now the next thing we have is a vertical line test. Whoop, here it is. A vertical line test is when you're given a graph. If you're given a graph, you just have to show a vertical line test. A graph is a function when no vertical line passes through more than one point on the graph. If you can take a line and it passes that graph more than once. Oh, let's not do that. Let me get rid of that one. If it passes more than once through any point vertically, it is not a function. So here we go. If I move this, nope. Does it pass anything more than once? No. So this one is a function. Now over here on the right side, this sideways parabola, bam, no matter where it goes. Look at it. It hits here and hits here. So therefore, we have 2 points or 2 places that it passes. Therefore, it's not a function. Look at example 2, and what I want you to do is look at each of these and determine, using the vertical line test, if each of them is a function. And you're going to have to explain. So let's draw a vertical line. Okay, nope. Up, bam, right there, look at that. Instantly, we see that the point 2,5 and the point 2,2. Notice this. How many outputs does 2 have? 2 has 2 outputs. In addition, we can see that 5 also has 2 outputs. It crosses the vertical line more than once. So A is not a function. And it's very important you understand the reason. The reason is you can draw a vertical line through more than one point, which means there are more than one output to an input. Now B, the vertical line, passes. No matter where it is, it only passes once. So in B, it's a function. Function. Now just look at these. Which ones are functions? Which ones are not? A is a function. The vertical line test would pass. Number 6, function. The vertical line test would pass. 7, not a function. Bam, no matter where I put it, it goes through twice. Not a function. And 8, no matter where I put it, it crosses only once. It is a function. Now the next thing that we're going to talk about is the domain and range. This is a concept that a lot of students struggle with, and that's okay. But I want you first to look at this weird looking box thing. This is called a function machine. Here's what I want you to think about. Your function is just an equation. You'll learn more about what functions are later, but it's basically just an equation. So if you look here, the equation is y equals 3x. Easy. We've done that before. Your input is your x. That's what goes in. The output is what comes out. So as you can see, negative 2 goes in. So 3 times negative 2, 3 multiplied by negative 2 is negative 6. Negative 6 is what comes out. So your input is x, your output is y. Your domain is all of the function is all of the numbers in the set that are possible input values. So the domain of a function is the set of all possible input values. The range is the set of all possible output values. So in this case, your domain would be negative 2, your range would be negative 6. So in this example, we want to find the domain and range. So your domain, here's how you write it. You could say domain. We're going to abbreviate. Your domain are all of the x values. Well, look at our points. we have -3, -2. We have -1, 0. We have 1, 2. And we have 3, 4. Your domains are all the x values. So your domains are -3, -1, 1, and 3. Your range would be all of the y values, your output. So your range would be -2, 0, 2, and 4. Now, the domain and range of the next one is a little trickier. Since we do not have points, it's anything here, anything on this line. So let's look. Your domain is going to be the set of all numbers, which are x. It's any number. Now notice here your x value. This is where it can get confusing. Your x value here, it's -2, -1. So it starts at -2. And it ends at 3, 2. So your x value goes from -2, x is greater than or equal to -2, but less than or equal to 3. So the domain is every number that goes from -2 to 3. They're not just they're not just whole numbers or integers. They are every number. Now, your domain, I'm going to kind of make it like this. Your domain is the x value, so it's everything between these values. This is your domain. Your range is everything vertically. Anything between those values, that is your range. So your range goes from -1 to 2. So the lowest value is -1, the highest value is 2. So this would be your domain and range. If you understand it, move on. You can skip over this. If you don't, I'm giving you an example to look at. Domain and range. In number 9, my domain would be, let's see, -2, -1, 1, and 2. So my domain would be -2, -1, 1, and 2. Now your range, they go to the y-axis. Your range, oh, we forgot the 0. I see a 0 here. I didn't even see that point. My range would be, let's see, that'd be -2, 4, -1, 2, 0, 0, and that's it. Those are the only values of y. Now over here, it's a range of values. So x-axis goes from here to here. There's my x-axis. It goes from 1 to 5. So we know x is greater than or equal to 1, but less than or equal to 5. Your range goes from here to here, right in here. So my range would go from minimum value of 0, and notice though I'm using the y because that's your y-axis, and the highest value is 4. So from 0 to 4. Now, when you identify an independent and dependent variable, the variable that represents the input values, notice would normally be x, are the independent variable because it can be any value in the domain. The variable that represents the output, which is y, values of the function, is the dependent variable because it depends on the value of the independent. So y depends on x. Y depends on x. So when an equation represents a function, the dependent variable is defined in terms of the independent. So notice this. The dependent variable y is in terms of x, which is the independent variable. The statement y is a function of x, y is a function of x, means that y varies on what x is. X is independent. I can plug in anything I want. But y depends on whatever x is. That's why y is dependent, x is independent. So here we go. The function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take X gulps. So, identify the independent and dependent variables. It's pretty easy. What's X? Gulps. You can take as many gulps as you want. But the amount of juice that's in there depends on how many gulps you take. So, what do we know? A, part A. Y is the dependent, now you need to write this in a complete sentence, I'm just doing it for the iPad. A dependent variable. X, which represents the number of gulps, is the independent variable. So, what is the domain and range? Now, if you made a t-table, X and Y. If I plug in 0, that means I haven't taken any gulps, there's 12 ounces left. If I take one gulp, that means there's 9 ounces left. 2 gulps, 12 minus 6, 6 ounces. 3 gulps, that would be 3 ounces. And 4 gulps means I have nothing left. So your range is 12, 9, 6, 3, and 0. And that would be your answer to part B.